Turmeric is a bright orange powder found in almost every kitchen pantry. While we usually know it for its color, its chemistry allows it to react to the substances it touches in surprising ways. For centuries, it has been a staple across Southeast Asia and India, traded in open-air markets as an essential part of daily life. Its most common job is in the kitchen, where it gives curries and stews a deep, earthy yellow tint. Beyond cooking, you will find it in health supplements and traditional medicines, often concentrated into small yellow capsules. It is also a highly effective dye, used to stain cotton and silk fabrics a permanent, vivid yellow. This ability to color things is more than just a surface-level feature. By looking at how turmeric reacts to other household ingredients, we can actually see its chemistry at work. We can observe this behavior by gathering a few basic items: water, a box of baking soda, and a packet of turmeric powder. First, we dissolve a spoonful of baking soda into water. This creates a liquid that looks exactly like plain water. Using a cotton swab, we use this mixture to write a word on a piece of white paper. As the liquid dries, the message completely disappears from view. The paper now looks untouched. To bring the writing back into view, we need to apply a substance that will react with the dried baking soda left behind. Chemicals react differently based on their specific properties. Understanding these properties helps us predict how one substance will change when it meets another. Scientists use a scale to group liquids into two categories: acids and bases. Acids are common in the kitchen, like a freshly squeezed lemon. On the opposite side are bases. Our invisible ink ingredient, baking soda, falls squarely into this group. Turmeric is unique because it acts as a visual sensor. It changes its physical appearance to signal which type of chemical it is currently touching. When turmeric comes into contact with an acid, it remains its original, bright yellow color. It doesn't show any visible change at all. However, when it touches a base, a chemical reaction occurs. The yellow powder shifts to a deep red. Since our hidden message is made of baking soda, a base, we can use turmeric to trigger that color change and reveal the writing. To create a solution that we can spread over the paper, we mix our turmeric powder with a small amount of rubbing alcohol. This creates a liquid with an intense color. It is a good idea to work carefully, as this mixture will stain almost anything it touches. Next, we need a soft tool that can apply the liquid evenly without damaging the dried baking soda on the paper. We can make a simple applicator by bending a pipe cleaner into a small, rounded loop. Tucking that loop into the end of a plastic straw gives us a handle, making it easier to control. With our turmeric solution ready and our applicator built, we can now see if our baking soda message will react as expected. We start by dipping the pipe cleaner loop into the yellow turmeric mixture. Then, we lightly sweep the solution across the surface of the paper. On the parts where we didn't write anything, the solution stays yellow and eventually dries into a standard yellow stain. But the moment the turmeric touches the dried baking soda, it turns a bold red. The base causes a color change right on the page. Clear, dark red letters emerge from the paper, standing out sharply against the yellow background. This immediate color shift from yellow to red provides a clear visual result of the chemistry between the turmeric and the baking soda. By using a common spice, we have demonstrated how certain substances can act as detectors for the chemicals around them. This proves you don't need a specialized lab to observe science. These reactions are happening right inside your cupboards. You can try this yourselves by using baking soda and turmeric to create and show your own hidden messages. Observing these small, everyday reactions helps us better understand the chemical rules that govern the world around us.